World War One?
A bit earlier.
Oh, okay.
I can liberate Hanover. What? Why is that a war goal? Doesn't make any sense.
So what year is this?
1836,
Yeah,
just after the Napoleonic Wars.
and right after Queen Victoria died.
Mm-hmm.
No, Queen Victoria dies in 1901.
Oh, okay, this is when she was born, I think, or when she. Yeah, or it was when it started. So it was 36.
So what's the strategy? Like, you fight?
It's like, imagine realpolitik, right? Great
Mm-hmm.
Power War,
Mm-hmm.
that sort of stuff.
So like you make coalitions?
Yeah, lots of it's economics. There's lots of economics, market based. The great power politics. So like you're trying to, I don't know, become dominant in your region. You know, there's lots of like diplomatic actions that you can do.
Mm-hmm.
But yeah, it's generally a fun game.
Mm-hmm. I
So
mean,
are
but
you single, Mr. Slave, or
I don't discuss my private life.
I mean, what are the odds of you going on a date with me?
I am not gay. What are you gay? What are you gay? Do you know
Is
the meme? What are
Silesia
you
yours?
gay?
Is Silesia Poland?
What did you say?
Is Silesia in Poland?
Silesia is Polish, yeah.
Okay.
Wait, are you gay?
I am gay, yeah.
What? Everyone on the server is gay?
No, just me.
Oh, okay.
You could say Gamma's about 10%.
Hmm.
I can sway Russia.
So
Yeah, do that.
would you say there's a correlation between being gay and being part of big physics?
Yes.
Absolutely.
Like I think you're less likely to find gay people on a flat earther
Okay.
server.
Well, why do you think that's the case?
Russia sides with
I
Austria.
think gay
Or Russia.
people like my intuition is that, that the
I think it might
mainstream
have to
is
do what
gay.
you want to do.
That's part of the reason why Putin hates the West,
Okay.
and the right
Wait,
wingers hate the
just a
West.
second, Mr. Slave. What did you say, Gamma?
Okay. The UK has joined. Russia has joined. Yeah,
Yeah.
we're gonna have to do
Do
it
it the
again.
other way. Let's just do it the other way. Yeah. Oh, I think gay people don't like flat Earth as much because gay people statistically have a higher IQ, and also because
True.
because
Okay.
like gay people are less likely to be religious flat earthers. Mostly are flat earthers because of religion. So you know,
Do gay people have a higher IQ, Jackal?
yeah,
It's probably
Why?
just because there's more statistics for gay people in Western countries, so it's
yeah,
higher.
exactly.
Yeah.
Oh, so gay people. That does. I don't think that makes any sense.
It
Like
there's
let's.
more people who are openly gay in Western countries. Western countries have higher IQ, so it's going to be sided towards Western countries, so high IQ.
I think we can disprove that. So if we look within a Western country, wouldn't you say that gays have a higher IQ?
Well, do you think the Angolan gays have high IQ? That's a good question.
Oh god, 69 IQ. You know, apes have a higher IQ than Angolans.
So wait, what are the stats? What are the statistics? Do gays in the West have a
Okay,
high?
it's just honestly, it's just because flat earthers are probably quite homophobic, quite old, and quite religious. So they go against the norm of what gay people typically are: younger, um, more intelligent, less religious, and less interested in flat Earth. In fact, I know I'm the one of two gay people, right? That are in. I've been here for a year, and I only know one other gay person who's into this.
and it's Embo.
Hmm.
I wish Embo was gay.
Who else is gay?
The femboy guy who's in the text chat usually.
Oh yeah.
I'm a very hot gay though, Mr. Slave. If that makes any difference for you, like I've got nice smooth thighs, and if that's your thing.
Usually, no, I'm not into gay men. I'm into forced homosexuality. Have you ever heard of that?
What?
No.
Wow, that's interesting.
How do you release a country?
We're gonna have to learn the entire system, but for Russia now.
Well,
Great.
it's the same principle. It's just that I'll be a bit bigger, and you could probably give me land because I'll already be Poland.
I mean,
Um,
the reason why flat earthers, I would say, exist is because of you.
Because of gay people.
Yeah.
Okay.
Like
well,
imagine.
yeah. I mean, I don't think he's wrong. I think that the cultural changes of the 21st century probably encourage their
That could be true.
It's like an action reaction. So gays have taken over all the institutions. So the
don't press
normies.
play yet. By the way, I need to pick. I need to. I need to decide how I release a country. Go on, continue. So what were you saying?
So like a normal person, not a normie, but a normal person, an average person sees that the gays took over the world. That what they call, they call it the global homo. Have you ever heard the term global homo?
I've heard global homo. Yeah, yeah,
Right, global homo just means that the homos took over the world.
yeah. They did. Yeah.
Right. So like a normal person who is, average, is pretty much a dummy dum dum. He's like he's looking at that and he's upset that the gays took over the world.
Yeah, they did.
Right. But he's
Well, not
upset.
the world. I mean, maybe the West,
The
right?
West, yeah. And the West is in control of the world. So a normal person, a non-gay, normal person, it makes them upset. It makes me upset. I think that's part of why I'm into forced homosexuality.
What do you mean by forced homosexuality?
It's a genre in sex. It's a fetish. That's like asking me, what do you mean by any other fetish? There's many fetishes, so it's just a fetish.
Right. So you're into you being forced to be gay or other people?
Me. It's also
Okay.
it's cuckoldry. Have you ever heard of that?
Yeah, yeah. I've heard of that.
So I'm into
Don't get
that.
Freckle started on that.
Right. Okay. Yeah. I mean, he's giving me too many ideas, to be honest. Um.
I'm giving you too many ideas
Yeah. Yeah.
about what?
Forcing you to be gay.
No, 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 not you. You forcing me to be gay is not sexually enticing. A
You
chick.
don't know that. The whole idea that you're speaking to a hot twink that's just showing you his thighs and you're trying to resist the impulse, but you can't because the thighs just look so juicy.
No, it's the fact that the thighs are so disgusting that makes it so. That's what makes it right. I'm into forced homosexuality because I find it so revolting being forced into it by a chick, not by you.
Oh,
So
what?
You're not the first person who's had that disease. Where do I? Okay, can you tell me how I release a fucking country, Gamma?
that disease, you called it a disease?
Yeah. How do I release a country? I don't know how to do it.
Okay, do you want to discuss physics in the background?
Give me a second to figure out this first, and then we can
Yeah.
talk all the physics you want.
Oh.
Yeah.
Right. What do I do?
Are you able to? Where is it? Liberate
Where's
subjects?
there must be but I'm pretty sure there's a list somewhere of countries that I have in my realm, and I can just release them. But I don't know where it is.
Yeah. Hold on. Let me see. Mine.
Oh, wait, no, that's not it. Release subject. There we go. Found it. That was fucking painful.
Where isn't diplomacy? Okay.
Yeah, because it's not my intuition that it would be in diplomacy. It would be like in some sort of domestic thing.
Who's Lori?
Releases independent or releases my. I mean, it saves me a war, right? And we can. There we go. There we go. All right, I'm Poland now. All right, continue. What you want to talk about? Wait, hold on. I need to sort this out with my good friend Gamma. Right,
you
so I'm
just-
Poland now, right? Which means that you're going to help me take Prussia on, right?
Yeah.
All right, good.
Yeah. Let me do this. Can I bankroll you if I can give you infinite money?
But I'm so poor.
Yeah.
Right, we're gonna.
So the
Can you give me
way
Krakow, please?
Yeah. Hold on. Let's see. It would be in diplomacy. Least subject. Huh. If I grant on market, maybe you can like. What does it say when you click on Krakow?
Anything.
Oh, I can just grant independence. Maybe then you'll.
Oh no, because then I'd have to go to war for it. All right. Can you just give it to me instead?
No, I released them.
Oh, okay. I'll figure that out later.
You should be able to. They want to join you. You should have like ultra high relations with them.
But see. Russia wants an alliance, apparently. Let's see. Diplomatic actions. I'm just don't know if I'm powerful enough for a country to want to.
wait, just so that I don't waste my time, do you
We
know?
will get into physics. Don't worry.
Are
We
you?
are on the road to that.
Do you know
Declare
physics?
interest in Krakow.
I know a lot of physics. Yeah. A second. Sorry, I know. I promised you physics, but give me a second.
Oh, okay. I kind of fucked up. I could just do it like this.
Oh, yeah, you should have done that the first time.
Yeah. Let's do it like that. And then
Right, I'll have to go to war for Krakow now.
West Galicia is yours as well.
Yeah. It's de jure Poland.
Do you want me to come back?
What do you think, Gamma? Do you want to talk about physics or no?
I think we should go to our own goal, honestly. This is going to be annoying for everyone.
Just turn nice fucking music. All right, what do you want to talk about physics about? What do you want to talk about? Tell me the physics you want to talk about. Gamma's going to take the lead because he's actually a physicist, graduated from the University of Physics.
University of Physics.
Mm-hmm.
I mean, do you believe in the wave? Like so, Sean Carroll says that the universe has a wave function. Have you ever heard him say that?
Is this towards me?
Yeah, it is.
Yes. I don't know what exactly that would entail, though.
Entail? You mean the universe has a wave function?
Yeah, I don't know what exactly would that would entail. The universe having a wave function.
Can you make any sense of that statement? Let me ask you.
It doesn't-
I'll ask you a simpler
doesn't really-
question. Do you think the electrons, the way it orbits, is described by a wave function?
Well, electrons don't orbit.
Well, I can't hear you.
Electrons don't orbit.
Electrons don't orbit?
No, I thought you agreed with big physics.
What?
I said I thought you agreed with big physics. You know how electron orbitals work. They're called orbitals, but they don't orbit the nucleus. There's just areas of where they potentially are.
What do you mean? But the
Bohr is
Bohr,
like 100 years ago.
yeah,
I
but
have a question. Did Gamma, do you actually have a physics degree?
Hell no.
Okay. I wondered if that was an
wait.
exaggeration. Gotcha.
So wait, but Bohr made predictions. I mean, the Bohr model has explanatory powers, right? He explains very
It
well.
does.
Right, he
Ele-
explains the colors of the spectrum very well, very
elec-
accurately.
electrons exist in shells that are analogous to the Bohr orbital model.
Not according to Bohr. Bohr didn't say electrons
Well, he
exist.
didn't. He
Dude,
didn't. He
Bohr is like
didn't.
100 years ago. You're pretty late.
One second. First, Bohr said, right, the Bohr model is that an electron is orbiting the nucleus, right? And he explained that it orbits n lambdas at n times lambda at a integral multiple of the wavelength of the electron, and the right, and the wavelength is derived from de Broglie's formula. So,
Yes, but
mhm.
they aren't like actually orbit. Like they aren't doing an orbit as you think they are. They're more like spheres of probability where they could be. They're
I
not
don't.
doing
That's
orbits
not.
around the nucleus.
That's not. That does not. As they say, that does not compute. I cannot even understand what you just said. I don't know. What do you mean by
Yeah, because that's
probability?
quantum mechanics nonsense. So I agree.
What do you mean you agree? So are you agreeing with me or disagreeing with me?
I'm agreeing with big physics, as you would say.
Okay, so let's talk about it. So Bohr, the Bohr model is that, right, you agree that the Bohr model is the electron is orbiting the nucleus, right?
I agree that that's what it says. Yeah.
Okay, and the Bohr model makes predictions. Based on this model, there is predictions about the colors, the spectrum of different shell.
Here you go. This is what I'm talking about. Here's a hydrogen wave function for. Have you never like this is like kind of like high school stuff. Um,
What do you mean?
atomic orbitals. They're not act. They don't. Uh, here you go. Here are the first five atomic orbitals,
Right, but I'm talking about the Bohr model.
which is not really what we. It's a good simplification of it, like Rutherford Bohr.
Was it like 12588 or something like that?
One second. The Bohr model makes very specific predictions about the
I'm
colors.
not saying it's wrong.
Okay,
I
so
get
if
it.
you're not saying it's wrong, then what's left? If it's not wrong, then it is right. And if it's right, then Bohr said the electron orbits the nucleus.
Okay, what do you think orbit means? How about that?
It literally orbits. It runs around. It has a velocity.
Yeah. Okay. And can you look in the general chat?
I'm looking the general chat. Let me see. Why don't you use the side chat?
Because I like interrupting conversations in the general chat by posting pictures.
Sorry, but I don't have audio and neither a mic. That's the general chat.
Huh?
Your submissive honey bunny.
It's two above general VC.
Two
Yeah, I
above
like
general VC.
posting
I'm at
stuff to
general
interrupt people's
chat.
conversations.
I'm looking at the last message in general chat.
That's Al Trucker, right?
Message could not be loaded. Jump. Um.
Oh boy.
Oh. I'm looking at the side chat of the general chat. 1 second. Okay, jump to present. Al Trucker, experiment with dihydrogen
Yep.
monoxide
Yep.
in
Scroll
various.
up.
Yeah.
Scroll up. Scroll up. Not far.
Yeah, I
View
see.
36.
Yeah, I see. Yeah, I see these shapes. Yeah, this is I guess what what the wave equation says.
Yeah. Probabilities of like of where
That's
the electrons
not.
are.
That is not what Schrodinger said.
I, you said that's what Schrodinger said.
No, I never used the word probability.
Well,
That
that's what it describes. It describes the
no, it
probability where
doesn't.
the electron is.
That's incorrect. That's maybe big physics. That's what big physics says. That's what people
I
say.
thought
I
you agreed with big physics.
no, no. I agree with everything, but not the interpretations. I agree with Schrodinger's equation, but it has nothing to do with I mean, you. I guess you could maybe use it for probability. I don't know. I don't know enough probability, but Schrodinger's wave equation is just assuming, right? Schrodinger just took de Broglie and Bohr seriously. That's all it is. He said, "Oh, so the electron is waving around the nucleus. The electron is a wave. So let's use the wave equation, the standard wave equation, to describe the electron, and let's right. Basically, that's it. Let's throw in de Broglie and energy conservation and Planck and Bohr. He threw everything in, and that's it. So Schrodinger's wave equation is just a more accurate Bohr model. But Bohr's model doesn't describe the wave, doesn't use the wave equation, but it assumes that the electron is waving around the nucleus, just like Schrodinger did.
Yeah, and the hydrogen wave function, the one I sent, is just the probability of finding an electron in a given
No, it's
region of
not.
space.
No,
What do you,
that's
what
your
do you,
interpretation. That's incorrect. I disagree with the
all right, what's your
interpretation.
interpretation of it?
It's a wave. This is the way the electron is waving around the nucleus.
So why is there some regions of the of space around the nucleus where there's just no probability of finding the electron?
It's just this is what the wave equation predicts based on assuming the electron is waving, assuming the electron is a wave, assuming de Broglie, Planck, Bohr. That's what the wave looks like. That's it.
So that's why there's some places where there's just no probability of finding the
It's
electron.
there's nothing to do with probability. I mean, you could interpret the wave equation of an ocean wave to be something about probability. You could do whatever you could. I don't even know what it means. I mean, if you know the shape, if you know the behavior of an electron, if you know how it behaves as a wave, you can use that behavior to predict um, finding it based on the behavior and I guess Heisenberg as well. But you can use but the wave equation, the way Schrodinger intended it is he just right. He was asked by that professor that invited him to speak. So he was asked to speak about de Broglie, to make a presentation about de Broglie. So he made the presentation, and then he was asked, so if it's a wave, what's the wave equation? He said, hold my beer. Took 6 months and came back with a wave equation to describe the wave that de Broglie described. He just took de Broglie seriously, that's all. I What's the question? Is anybody here? Is everybody gone? Hello? Hello?
Hey, I had to step away for a bit, so I just came back.
Where's everyone? I was speaking. I was promised a conversation. I waited patiently, as they say.
I don't know what happened to Gamma and Nohack. I wasn't here for that. Um,
Hmm.
so
Hmm.
I can speak to the electron cloud model.
Great. Let's talk.
So
Hmm.
so these show the clouds show an area where the electron is likely to be. Okay, and the higher the brighter the color, the more likely the electron would be found in that area.
But the electron is not a particle; it's a wave. So those words are meaningless.
Well, okay, that's what the model means.
No, it doesn't.
The electron most definitely is a particle
What's your evidence for that?
because it has a definite location when it is discovered. It's not smeared out over a large area.
It literally is. It has a delta X, delta P that is
Its
not.
its position has a probability term, yes, but once you find it, it is in one definite spot. It's not in smeared out over a large space. It is in one location.
No, it's not. I mean,
Well,
it's.
I'm sorry. I'm sorry if you don't like it, but that's unfortunately every CRT shows that that's how electrons behave.
What's a CRT? Cathode ray
Me,
tube?
Mr. Slave, can I ask you something? Instead of stories, do you have any claim? Because saying something is not, which is the opposite from the common knowledge, you can say until tomorrow, but you need to bring evidence for what you're saying.
So when you send when you bounce photons off of electrons, you can scatter photons off it. That determines its location.
Yeah.
It's not just that. It's a CRT is a cathode ray tube, also known as a classic TV. You can fire off individual electrons off of the electron gun, and they will impact in only one spot on the shadow mask. Not in a million spots, not all over the shadow mask. They'll just impact one specific location.
There's not a contradiction to anything that I said. So,
That is a contradiction because if it was a wave, if it was a wave, continuous wave, then it would produce a uniform effect. That doesn't happen.
so
Electron position is quantized. It will occur only in one spot,
yes.
even if the wave function says that it is the probable the even if you solve the wave function is smeared out over a large area. Say, for instance, during a double slit experiment, you will only ever find individual impacts on the target.
Yes, that's not a contradiction to anything I said.
Well,
You're
it,
explaining. Wait,
How not?
you're
How not?
explaining.
So you're
If,
asking,
if
yeah, you're asking how not. So
Yeah.
it's a wave packet. So we're used to waves just dispersing. Like when you make a wave, you're used to imagining like a water surface wave that you tap the water and it just goes everywhere and dissipates.
yes,
That
that's one of the properties of wave. It is a continuous function.
so, a wave packet, like a photon, um, is something that exhibits the behavior of both a particle and a wave.
no, it's a wave
Yeah.
packet. No, there's nothing moving. There is no particle moving. There's only energy propagating, but it's confined to a region.
So
That-
does the energy propagating have mass?
If it's an electron and interacts with the Higgs mechanism, sure.
Okay, so we have this thing that is propagating with mass
Mm-hmm.
that has hits with force, albeit very little force,
Mhm.
in one location.
Yeah.
So why would I describe that as a wave?
Because there's nothing moving. There's only energy propagating through a field. I call it the ether. You
Okay,
can.
but that is your interpretation of what's going on. That is
Okay.
not. I don't agree with that interpretation. So how do we figure out whether or not that's an accurate way to describe it?
So that's why I'm going back to Bohr's model. I mean, Bohr said it's a wave and it's waving around the nucleus with a definite velocity, and he made definite predictions, and these predictions came true, or he had an explanatory power very accurate. And
So in Bohr's model, an electron is like a little planet
no,
orbiting a sun. It's a
no,
little particle.
no, it's not.
Not quite, no.
It's a wave. It's literally the opposite. It's just a wave.
Right. So
What's the question?
carry on.
I mean, it's just a wave. And
Cool story.
it's it's waving around the nucleus in n times lambda, because if it were not n times lambda, then it would be discontinuous. So it's exactly n times lambda. So the first orbit, it's not an orbital, it's an orbit. Just like Bohr said, the first orbit is n equals 1, and it cannot be less than n equals 1 because it's a wave. That's why it cannot spiral into the nucleus. It's blocked.
So wait a minute. Wait. Where do we get that Bohr described electrons as waves? My understanding of the Bohr model is that it described electrons as particles.
No. Ask me questions, I'll answer. It's just
How did he where did he describe it as a wave?
he said it's n times lambda. That is the definition of the orbits of the electron. That's exactly his model. It's just n times lambda, where n is an integer greater than 1.
So if you look up the Bohr model,
Mhm.
does he say in his model that the electron is a wave?
It's actually not critical what he said. I honestly don't care what he said. It's
Okay.
fine. It's fine as long as
Hang on.
he. Mhm. You want to say something? Did you say hang on?
I think he's talking to somebody else right now. Somebody's started talking at him.
Oh, okay. So, any questions? No questions? No one disagrees with me?
Everybody disagrees with you, but there's no questions.
How is that possible? If you disagree with me, I mean,
The thing is,
I don't know.
you need to say something that we can actually begin from, that you do agree about relative, like the thing that you said about gravity being a force. Why? Okay, can you start from somewhere?
right now we're talking about the wave function, which I'm more interested in quantum mechanics right now. If you want to talk about gravity, I have an ether. I mean,
Yes, but I doubt your ability to talk about quantum mechanics. I want to go to simpler terms, like actually mechanics or simple physics, which I heard you on the Awakening server, and I see that you don't even agree with the basic law.
I agree in general with everything from big
Or you
physics.
don't understand them and you call them ether.
No. I agree with everything from big physics. but I interpret everything with a unified field that the ancients used to call ether, and I think they had it right. So I interpret special relativity, general relativity, Maxwell, and quantum mechanics, the Higgs, dark energy, everything I can explain using ether. It's really very, very simple, very mechanical. All of quantum mechanics
And also
becomes
very wrong.
But it was such a word salad. I mean,
misinformation
are you
agents.
trolling or you being serious right now? I'm
Misinformation
really asking.
agents.
He's cosplaying.
Misinformation agents. Your audio it goes up and down, so I can barely understand what you're saying.
I don't give a fuck about my audio. Can you answer and not to change the subject?
What's the question?
You see,
Misinfo, your audio really is a little bit hard to listen to, but yeah, to give you the answer, he's cosplaying as a physicist.
I'm not
And has
cosplaying as a physicist. I just started studying physics 2 months ago. I barely know any physics.
yeah. So here's a good idea.
Mm-hmm.
Keep studying for 5 more years, and then once you've
Mm-hmm.
graduated, maybe then you can start having an actual input on the foundations of physics and how it's done. Because until then, you're basically just a completely clueless guy who thinks that he has something magical when the actual answer is you don't know what you're talking about.
also, I don't believe after one semester that you know anything, especially when the physics degree is mostly math at the beginning.
No, no, no.
And all the names that you throw, it's like you're playing.
No, 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 no.
You're not really
No, no, no,
studied
no.
it.
No, you misunderstand. No, no. I've studied physics my entire life, but not seriously. 2 months ago, I started studying physics, especially quantum mechanics, more seriously. That's what I meant. Like my entire life, I've known physics. I've always been interested, and so it's not
In what frame? Official frame, a
no, no,
degree frame,
no.
or you looking at the YouTube and deciding that ether is part of physics?
No, I mean, I'm watching everything. You can go to my channel and you can see exactly the day that I started doing my studies. And everything I've done, almost everything has been recorded. So you can track my progress. I'm basically watching YouTube videos, the mainstream YouTube
So
physics.
you have
Mhm.
no formal form of education to even understand the math behind the physics and how we arrive to those calculations or equations, and you open random videos and you say that you're now smarter than anyone around you
No,
because
no,
of it.
no, no, no. I have formal. I know quite a bit of math. That my math is not. I still need to improve, but I know substantial amount of math.
Really? What's a metric tensor?
I don't know.
Okay. That's kind of like general relativity 101. That's like day one, basically.
Yeah, that's
Tensor
exact.
calculus.
Yeah, I need to figure that
So
out.
you haven't even arrived at day one. Okay.
Yeah.
Yeah, do you think you're going to be providing input on how it should have been interpreted?
Hmm.
Gotcha.
Don't you think it's a little bit narcissistic to think you know better than physics, or guys that learn for 10 years and develop stuff behind it when you didn't even do the calculus,
No, I did.
or algebra?
No, I did.
It sounds like you didn't.
No, I did. I did. Just tensor calculus. That's exactly where I stopped. I started doing
Hmm.
Leonard Susskind's GR course, and exactly where he started doing covariance and tensor. That's where I got lost, and I need to get back to that.
Did you just Google it?
What do you mean Google it? Google
I
what?
think you might have. You probably should have continued because where you stopped is where actual understanding even begins. Like you've not even taken the first step. Like for instance, you don't understand the fact that if you look over here, this is the visualization of the solution of a wave function for a double slit experiment. But what you don't understand is that this is a continuous function. There's no stops at the individual points or something of that kind. But if you actually perform a double slit experiment in a lab, you do not get a continuous wave function. You get this. You get points of impact that follow the distribution
Wait,
of the wave function, but you do not get smeared out electrons. That's how you know that electrons are particles.
no,
However, their position is determined by the wave function. So
no.
you haven't even started. You haven't even started to understand what quantum physics is all about. Yet you think you can actually offer any input and trying to overturn or expand our knowledge. Like I hate being harsh to you, but you kind of need a slap.
Well, you're not being harsh. What you're saying is a logical fallacy. So I've
I'm
no reason.
sorry. I'm sorry if you don't like it, but that's what the math says, and thousands upon thousands of people understand the math. You don't, and
Look, you're just employing logical fallacy, so you're just wasting our time.
yeah, cool story, bro.
Excuse me, what's the logical fallacy? You don't understand what you're talking about? That's not a logical fallacy.
That's literally a logical
That's
fallacy.
fallacy.
That's not a fallacy. That's he doesn't understand what the fuck he's talking about.
Anyway, do you want to have a discussion about a topic or about me? What's your preference? Because I don't want to talk about me. I want to talk about a topic. So
You can pick a topic,
I'm
but you need to have an understanding and to come prepared to discuss a certain topic.
okay. So I'll ask again. Do you want to talk about a topic or do you want to talk about me? Because if you want to talk about me, I'm not a party to that. And if you want to talk about a topic, I'll gladly talk about a topic that is not me. So we can talk about any topic in the universe except for me. So, like,
Let me see if you follow. You wanted to talk about quantum mechanics,
for example,
right?
sure.
For example.
hmm
So the other guy told you he cannot put stuff in terms that you will understand in the state that you are right now after hearing a bit of your knowledge on this subject. Okay, so can we dumb it down? Can you present a lighter topic that you want to talk about?
Okay, so again, you keep talking about me, and I don't want to talk about me. I want to talk about a topic that is not me. So if you keep talking about me,
But do you understand? Let's change the subject totally. Let me give you a logic example. Okay. For example, me and you, we want to talk about cars. Okay. But you never opened the hood and you didn't uh, learn the parts. And you're right now asking me about how an engine works and how are you going to improve it. You see the issue?
no, you keep referencing me, and I keep asking you not to reference me. So if you want to talk about a topic, I'll gladly talk about a topic that is not me.
Do you
So
understand the example in which you want to make improvements about existing technology without an understanding the technology
you
and
keep,
expecting someone to explain it to you from zero in one discussion?
yeah, you keep referencing me, and I keep telling you, please, I'm not going to be a party to a discussion about
How are we
me.
going to talk about you without? How are we going to talk about? So what? You want to talk about stuff?
hmm
What do you want to talk about? Anything that?
Anything,
Well, you can't
anything.
talk about you,
Yeah,
but so you can sit here and talk about your knowledge, but we can't talk about what your knowledge is.
yeah. I want to talk about anything in the universe except for that one topic that is me. what I
Except for
don't.
what you know and how you know it, right?
Well, whatever has.
But we're supposed to listen to you talk about things without your basis of qualification about it, right?
Well, you keep referencing me, so as long as you reference me, I'm gonna ignore it. So if you want to talk about any topic in the universe,
So I think it's probably if we wanted to talk about something that's relevant here, I think that the answer would be to talk about how we understand the particle wave duality. Because that's something that interests me. So the
excellent.
example that I like
Mhm.
is Compton scattering,
Mhm.
where a photon,
Mhm.
like an X-ray,
Mhm.
is being reflected or not, is knocking electrons off of substance,
Mhm.
like pool balls. So this is like elastic collisions,
You
right? And that's a particle style behavior.
no, no, no. It's as soon as you say pool ball, that's when I wanted to stop you. You should stop doing that. That's the mistake you keep making. It's not. You just say wave. Whenever you want to refer to an electron, just say wave, and you'll see everything will make sense. It's a wave packet. We don't
So
usually.
have you ever played pool?
Yes,
Okay. Do you know the difference between elastic and inelastic collision?
we discussed that yesterday. So I think inelastic is it involves like loss of energy or heat. Like the system absorbs.
Right.
Okay.
And in an elastic collision, energy is lost, and in a inelastic collision, the energy is maintained.
No,
Usually in the
in an
I don't know if I have
elastic.
this backwards.
Yeah, elastic energy is. I mean, either way, energy is conserved. But in inelastic.
No. But I'm talking about in like if a car hits another car and the car that hits it crumples,
Right.
okay, and both cars
That's an
remain
elastic collision, yeah.
stationary.
Right.
Yeah.
So some of the energy goes to heat. Yeah.
So so if in that case, what we're talking about is when I say pool balls,
Mm-hmm.
I'm discussing how we perceive the specific collision that's involved that produces the effect that we recognize as a as a particle style collision.
Right, but okay. So let's imagine the photon. The photon is also a wave packet. So you have a wave.
Okay, yeah.
There's a wave packet. It's a wave. It's waving through something. I call it the ether.
No, that wait a minute. Wait. We don't agree on that.
Well,
We agree that it can be described as a wave packet, yes, but we don't agree that it's waving through something.
well,
We
I'm
just don't. I mean, I'm sorry, but that we do not agree on that.
I'm not here to agree. I'm here to.
What
I'm
what
not-
what do you mean even waving through that? What do you mean by that?
So the idea that it's waving the idea is that like sound waves and water waves are water waving, sound waves are air waving, right? The idea is that it's a mechanical compression wave,
Yeah.
and that light is something like a mechanical compression wave through the ether.
Well, that would be a gravitational wave. Light is, it's two dimensional. It's like orthogonal. It's up and down and right and left. It's different.
I don't know what does that mean. I don't understand that.
So
Legit.
This is the difference between a longitudinal and a transverse wave.
yeah, exactly.
Yeah.
That's what I meant.
Okay.
It's not. There's no. I mean, there is
Yes,
compression.
I understand that.
The compression
Yeah.
is not in the direction of motion of the wave. That's
Sound is a longitudinal wave. Photons are transverse waves, and the electromagnetic fields.
yeah. So yeah, but there is still compression. But okay, but
not compression.
it's fine. What?
They're not compression. A string vibrating is not a compression of the string.
Yeah.
Okay, I mean,
Similarly, a wave on a lake is not a compression.
but uh, the EM wave is a compression, right?
No. It is a transverse wave, not a longitudinal wave.
No, but still, if something is waving,
Yes,
No.
but it's not compressing.
no, but
Well, it's the we typically describe it as an oscillation in the electromagnetic field, but it is not an object that is waving.
hold on. So if we view the universe as if we view the universe as a three-dimensional fluid, if we view
We
the
don't,
universe,
but okay.
yeah, fine, I do.
Well, yeah, I don't even know. So if we view the universe as a three-dimensional fluid,
Mm-hmm.
meaning that if we pre-assume the ether,
Mm-hmm.
then we describe things as ether, but that's a tautological statement.
What do you mean? Where's the
Let him cook.
tautology?
Let him cook.
Yeah, I don't see the tautology.
Let's pre-assume the ether. How do you confirm? How do you? What would that imply? So you can formulate your hypothesis. Ether is a thing.
Mm-hmm.
Then what would that imply?
So there are no particles in the universe except for the particles that make up the ether. That's the assumption, and they are.
Okay. So what would that imply?
So let me just finish. So they are much tinier than the electron and the photon and everything else. So the electron is a wave in the ether. It's a wavelet. It's a wave packet.
Yeah, this is the theory. This is the luminous versus ether theory that a lot of people held. Like this is what people thought until roughly the Michelson-Morley experiment.
It's not entirely analogous, but let's let him cook. We'll see. We'll see when he, if ever, he produces an experiment to confirm his hypothesis.
I have multiple experiments that I've made videos about, but I didn't write all the papers yet. We can come back to that.
Cool. So what are they?
Can you open one for us, him to us, and
Can you tell him that I have no idea what he's saying? He's got to fix his audio. Anyway,
And carry on.
okay. So
I said, sorry. Now you hear me?
Yeah.
Yeah.
I said, would you stream it and show us one example of experiment and maybe explain and we ask you?
Sure. I mean, I'd rather talk about theory.
No, because you said you did experiments. We want to see
No, I didn't.
stuff that work.
No, I didn't.
I mean,
said I didn't
let
write.
him cook.
I said I didn't write the papers that explain the experiments, but I did make videos, multiple videos. So I'd rather
So he's
not.
asking. So what misinformation was asking about streaming it, which might be good to do, but for right now, I'm with tutorial. Let's I'm so what I think you're doing is pre-assuming, if I look at the universe as having this fluid substrate, pervasive fluid substrate, then everything makes sense. And I have a very elegant explanation for all this stuff. And if I look at it and that gives me this, sorry?
I lost you. So you agree that if we assume ether, then you have no more questions about physics?
No. Well, no, I don't. Especially not if I assume that that the explanations that ether gives are testable, because that's something that we definitely don't seem.
We'll come back to the. I said we can. I'd rather come back to the experiments because I've already made multiple videos about them. So I'd rather do theory right now, and we can discuss my proposed experiments another time. But it's up to you. We can discuss my proposed experiments right now. It's totally up to you. I'd rather talk about theory.
Yeah, just go ahead and explain your theory, I guess.
Okay. So if we assume, so I assume that the universe is filled with only one thing, and that is a fluid. Everything that we perceive as matter and light and energy, these are just waves in this fluid that the ancients called ether. So my ether is everything. It's the luminiferous ether, but it's also GR's ether. It is gravity as well, and it is the quantum field as well. It is the Higgs field. It's dark energy. So everything is inside this
Everything.
fluid. Excuse me.
Yeah, everything is ether. Your taxis are ether.
What?
Death is ether. Everything
What?
is ether.
Basically,
Carry
a field of and in the ether
What?
in this theory.
What?
Everything
Wait,
is
one at a
pure.
time. Did you say my taxes are ether?
I'm joking. Carry on. I'm going.
And what did the other person say?
He's just simping for you. So carry on, and if you
Okay.
can, try and speed it up a little bit.
So, so an electron is a wave packet in this ether, meaning it's a wave of energy. It's a propagation of energy, of compression of sort, transverse, and so on, in this ether. But it holds its integrity. It doesn't disperse. So it's not like a normal surface wave that we're used to. It's a wave that keeps its integrity. It cannot split in two.
Well, it does split in two in the double
Yes.
slit experiment.
Yes. You're right. It does split
Yeah,
in two. That's true. It does split in two.
So-
So it
So
can.
I was about to say, if a wave cannot disperse, then it's not a wave. But whatever. Carry on.
Yes. So it is able to split in two. So the photon is able to split in two in the double slit experiment, I guess.
Okay, gotcha. Cool. So
But
you haven't. Okay, gotcha. So you haven't really thought through
no, I
the entire
didn't.
thing, because one objection immediately made you change.
So
Okay.
I don't know if we were ever able to actually send a single photon.
Yes, we are.
A single photon? How do we know?
Yes,
How do we know?
individual detections. You've never seen a photo multiplier tube or a double slit experiment? Kind of an oopsie
And
there,
what
but
we've
that's okay.
seen from the double slit experiment is that photons are extrapolated as a toroidal field. Okay. So nothing exists outside of observation. So this proves the flat Earth.
There you go.
It does.
Anyway,
If
yeah, I have to
understand
work.
that we are living creation itself because it's a hologram
Anyway,
due to the
anyway,
experiment. Okay.
anyway, yeah. I mean, I need to work out the details, but it keeps its integrity. It goes through two slits, but it's still one. It somehow does that.
Okay,
Some-
so it goes through two slits. Okay.
One
So
second.
it
Let
either
me just-
acts as waves or
let
it
me-
acts as particles, depending on it if it's
No,
observed on
no,
it.
no, no.
That's
Let
how it works.
let me finish. Let me
I
finish.
mean, no.
It's my theory. I'm presenting.
That's how it works.
No, I'm presenting.
Let the man cook.
I'm presenting my theory right now. Anyway, so an electron is a wave. Now, when it goes through the double slits, yeah, very good. So it's a wave. No, it doesn't do that. No, it doesn't do that. No, it maintains its integrity. It goes through, and it hits and is detected as one particle. It's not a particle, but it's detected as one thing. When it's captured by a nucleus, by a proton, then it waves around the proton with a specific velocity and momentum, but it's waving. It's waving, and it can only wave as a multiple of lambda. And when a photon when a photon enters the system, it imparts some of the it imparts its momentum. If it perfectly fits the energy, then it imparts the momentum onto the electron, and the electron goes increases the orbit, and
Is there? Okay. Can you speed it up a little bit?
well, no, this is maximum speed. So now the photon has been
I'm just
absorbed.
saying that if this was a pre-recorded video, I'd be right now about setting it to 200% speed.
Yeah.
You can ask
Well,
questions
so
if
what
you
it-
want.
do
I'm
you
just
want-
1 second. Let me
Okay.
finish. So, look,
Yeah, you can finish.
if you have any questions, ask. I'm just explaining
Well,
to
this
you.
is how it works.
1 second,
Okay.
Vanu, please let me finish. So, um, so the photon is um is absorbed somehow into the system, into the
The wave
hydrogen.
collapse function of
No,
consciousness. That's what it is.
no.
I mean,
No,
That's
that's not.
exactly
I'm
what it is.
presenting
Don't
Vanu.
interrupt him, Vanu.
Vanu, I'm presenting
That's what it is.
Vanu. I'm presenting my theory. So let me
Your
finish.
theory,
My theory. So let me finish. So
not the real theory.
so the photon is absorbed into the system. It's no longer there. The electron now went up to the next orbit, but it's unstable. At one point, the electron falls back, and as it crashes into its lowest state, the impact creates a vibration, and that is identical to the original photon. So an identical photon is created and is sent off at a specific location and direction as a wave packet that is again
Does
waving.
does this photon have a specific energy?
Yes, it's the exact energy
Gotcha. Okay.
of the
How
photon.
do we? Okay, how do we calculate it? Because right now you've been serving me up a whole lot of word salad, and it's getting a little dry. So I need some ranch. I need some of that math, some of those equations to sauce this thing up.
I'm not saying anything different than big physics. All
Big
the
physics, yeah,
equations
gotcha.
hold. All the equations hold.
Okay, gotcha.
What?
So what is what is the equation for the energy of a wave?
E equals h times f.
Wonderful, good stuff. Okay, so how do you solve?
Well, it's E equals mc squared, isn't it? Energy equals mass times acceleration.
No, there's
squared.
no mass. The photon doesn't have any mass.
Well, so
stuff.
the energy is the mass, but slowed down. That's what that equation means.
Okay. Anyway, what's the question?
So how do you solve?
Wait. Mr. Slave, you are a flat earther?
No. No, I'm big.
No, he's not
I
a flat
agree. I agree with big physics.
He's not.
I agree with big physics on everything.
I'm a flat earther.
That's fine. I agree with big physics on everything except for the only thing that the universe is built on is the ether. Everything else is a wave in the ether, which is what QFT says. Quantum field theory, as far as I know, that's what it says. So everything I'm saying
Well, you're very wrong, but okay.
everything I'm saying, as far as I know, fits perfectly with big physics. I'm not saying anything against big physics.
Yeah, you are, but that's okay. Carry on.
What am I
So
saying?
let me ask you a question then about that. If what you're saying doesn't agree with physics as we understand it,
It does.
then what insight does your theory give us?
My theory gives you many things.
Okay, so let's go through one of the insights that if I adopt your theory,
Mm-hmm.
if I adopt your explanation or your interpretation,
Mm-hmm.
what becomes clear?
Everything, but everything is mechanical. There's no more magic. So you get special relativity, general relativity, quantum mechanics, black
Okay,
hole.
how so? How so?
Which one do you want?
Let's do
I would
general relativity.
I would like some mathematical description of the ether and how you can obtain, for example, Einstein's field equations out of it. You can start there.
No, so as far as GR is concerned, what I don't like. let's talk about the conclusions of GR.
Can you?
Mhm. Go ahead.
I mean, you said that you could get general relativity out of it, so let's go ahead and do it. Show us how you get general relativity out of whatever you're proposing. Let's
Right.
start
So
out with some mathematical description of whatever that ether thing
no, I
is
don't
that you want.
disagree. My point is, I don't disagree. I don't know GR. I don't disagree with GR. All
So
I
you don't actually understand. You don't actually know whether it comes out of whatever it is you're proposing.
so here I'll tell you here. So GR, for example, predicts Newtonian gravity, right?
It can be solved for that kind of a state, yes.
It reduces to Newtonian
Exactly.
gravity.
And
It's just
Newtonian
how you'd
in
actually-
certain very specific conditions, you can obtain equations out of it that's going to give you Newtonian gravity. So yes,
Okay.
that is true. But since you say you don't understand general relativity, you wouldn't know how that happens.
Right. But we all, so if you want Newtonian gravity comes directly out of out of fluid, right? Gauss's theorem, or Gaussian, whatever.
No, it doesn't.
Well, in Leonard Susskind's lectures on GR, he derives it, and the inverse square law comes out of Gauss's theorem, and
Well,
Leonard Susskind.
yes, there's a lot of effects in reality that do have an inverse square relationship. That is simply a function of certain basic facts of geometry, but that doesn't necessarily mean that gravity originates mechanistically out of whatever. And also, you still haven't shown. You claimed that general relativity comes out of your whatever ether, but you haven't shown a description of what the ether is. And by the way, a description, I mean like an actual quantitative theory, something that gives me something solid that I can make predictions off of. And then you haven't shown how you can derive general relativity out of your ether. So you haven't even started, let alone gotten anywhere. So let's get this Doom buggy, fired up, and let's go. Let's crank some math.
I mean,
I'm dying of dry word salad here.
What is a falsifiable prediction that we could test to see if your interpretation is better than other interpretations?
I mean, I have at least 2 experiments that I can propose, but they've not been.
Okay, describe the experiments.
So one I mean, okay. I mean, you want to skip the theory and go to the experiments?
Yeah.
Okay.
Yeah, because obviously there's no theory there, so
I don't think the
we need to
theory
wrap
is getting us anywhere.
So when I first came with this theory, I became very happy because finally I understood the particle wave duality and gravity and special relativity and quantum mechanics. Everything became very clear to me when I started working with the ether model. So do you not see that? Do you not see that the ether model is a simplified model of physics?
You haven't described anything yet on the ether model. You've given us a whole bunch of words, not a whole lot of actual solid stuff we could calculate with. So go ahead and propose your experiment, and let's go from there. I don't know. So obviously you don't have any theory.
So I wouldn't necessarily say you don't have any theory. I think you have a theory, but in order to articulate it in a way that
He has a bunch of ideas.
I could understand it.
I
would say, yeah, okay.
He has a bunch of ideas for a coherent theory. I would expect some mathematical underpinnings. Some symmetry, some field equations, something there that I could actually look at and see what the thing is mechanistically made up of. Whereas right now, so far, it just seems to be musings of a stone guy.
Stone guy?
Stoner.
Stoner?
I have to step away for a minute. I'll be back.
Yeah, dude. It sounds like you're blazing that 420 real hard.
Okay, let's stop with referencing me like we did originally, because I'm not going to be part of that discussion. So if you want to talk about
let's go to the
anything,
experiments. Maybe there's something there.
No, but you claim that I'm not proposing a theory?
Yeah, no, so far I haven't heard anything that I would term a theory. Yeah, not yet.
So I have a unified field theory that includes all of big physics under one umbrella, under one
Cool.
model.
Cool, but I'm impressed you so far haven't been able to actually substantiate any of it. So
Ask me
let's go to
questions.
your experiments. Maybe there'll be something there.
No. I'm not gonna let you go. You're gonna have to convince me that you're not convinced of my theory. So just saying that you don't accept, just saying
You
that,
have
just saying that you don't accept my theory, or that you have unkind
no,
words,
I have
uncharitable.
not yet heard anything that I would qualify as a theory. So
Yes, you did.
um,
You heard.
no, I heard
You're
you make a
welcome.
bunch of word salad.
No.
But you haven't, like, if I ask you, for example, okay, what's this? What are the dynamics of this ether thing? You don't know. What are the degrees of freedom of this ether thing? You don't know. Are there
Well,
any symmetries in there?
Are you going
You
to
don't know.
Are you going to continue answering for me, or are you going to actually ask me
So
curiously?
what are the dynamics of this ether thing? And by the way, I expect some mathematical underpinning, something that I can actually manipulate to think about it.
I already answered that
Thank-
question. So I don't disagree with big physics. So for example, Maxwell describes the ether. I mean, Maxwell's equations describe electromagnetic
They don't.
radiation.
But okay. They don't describe the ether.
Yes, they do.
Where?
So,
I never seen a
Can you?
Maxwell equation.
so when you ask me for a
So
mathematical
there's
model, that's the
so there are
answer.
4 equations in Maxwell's in Maxwell's set of equations. Which of the terms there is the ether?
The permeability and the permeativity. That is ether.
Really? That's ether? That's those are numerical constants.
Yeah, of the ether.
So that's ether is a number.
No, these it's the permeativity and the permeability of the ether.
Okay. Otherwise we just call it a vacuum, but okay.
Fine.
So are you just relabeling vacuum ether?
I mean that I cannot understand how you can say that an ether has permeability and permeativity. How a vacuum
Permittivity, but okay.
I don't understand how you can say that a vacuum has any qualities. The definition of a vacuum is lack of. So if you agree that there is an ether, you just want to call it
So ether is the same thing as what we would call vacuum.
Why would you
Okay,
call
gotcha.
it vacuum? Why would you call something vacuum? Vacuum is the lack of.
Vacuum means there's no particles there.
Right. But
Doesn't
something
mean there's nothing there. It just means there's no particles there.
but look, something is there that has, I'm not saying what it is, but something is there that has permeativity and permeability, right? Or whatever. Permittivity and permeability, whatever the words are. Right?
Okay. Generally knowing what the words are is kind of the starting point, but yeah, okay.
Again, you're referencing me. Stop it. So, just don't.
You're not really sounding too coherent.
Yeah, again, you're referencing me. I will not be a party to that, so I'll ignore your comments. So, the E naught and the mu naught. So, those describe these are attributes of the ether.
So the ether is constant. It doesn't change ever.
Those are whatever Maxwell says. It's about the ether. Whatever Einstein said, SR, that's obviously a fluid.
What Maxwell is talking about there are vector fields. Those are vector fields. Not ether, not fluid, nothing like that. And a vector field is a mathematical construct.
It's a mathematical model of reality.
Yeah, sure. So that's why I'm asking, like, which of these terms describes the ether? And you say that only mu naught and epsilon naught, which would be vacuum permeability and vacuum permittivity, are the ether.
attributes
But-
of the ether. But
Okay, so attributes of the ether. Okay, cool. So for electromagnetism, nothing else is pertinent from the ether? Nothing else in there is ether?
the electric field is the ether. It's that's like
Okay.
saying
So
that's
the
like
electric field is the ether.
if you're looking at water flowing, right? You can describe water flowing with a vector field equation, right?
Sure.
They're exactly the same. So there is an ether flowing or an ether doing something, and these vector and these.
So the electric field is ether. Okay, got it.
Do you have any other questions?
And also vacuum permeability and vacuum permittivity is ether. What else on ether is it ether?
It's not vacuum, so you can call it
It's
vacuum.
just the names. It's just the name.
Not just a name. It's a word in English
Okay.
that means emptiness, lack of, and that doesn't make any sense. That something that is lacking has attributes. That doesn't make any sense.
Sure. So those three things in there. So capital E, mu naught, and epsilon naught are ether. Is there anything else in there that's ether?
Everything here, right? These equations, right? These equations can describe a fluid, for example.
Is rho ether on there?
Everything, look, so Maxwell gave us field equations, and we know that in reality there is elementary, what we call particles or wave packets, or there is at the end there's quantum packets.
Is del T on there ether as well?
What?
What about nabla? Is nabla on there ether?
It right, so it's exactly like you can have vector field equations to describe a fluid. So the fluid is real in reality, and the mathematical model is a model of reality.
Gotcha,
It's just
okay.
a model of reality. So it's a convenient tool.
So is ether the background medium, or is ether the things moving through the medium, or is ether just everything?
Ether is everything, and everything. I mean, so right now I am composed of tiny particles that, when we look,
They're bits of ether.
they're not bits of ether. It's waves in ether. These are wavelets in ether. So an electron is a wavelet. It's a wave packet. A photon is a wave packet. A quark is a wave packet.
Okay, so what are the qualities of this ether stuff?
Exactly what big physics says. What you say it's about the
which makes them indistinguishable from not ether. Because so far all you've described is, to me, so Maxwell's equations describe the interactions of the electric and magnetic fields, which are two different things, and the interaction of charged particles moving through that field and particles that have magnetic moment. So 4 different things in the Maxwell equations you say is the same thing. So I need to have some mechanism by which I'm able to ascribe the various parts to whatever you're saying. How do these behaviors arise in ether? I'm going to need an explanation about how all these 4 separate pieces compose together. There's actually also time, but I'm going to assume that you're going to say that time is also ether.
Everything is at the end of the day, there is only ether in the universe. The universe is an ocean, is a deep, deep ocean of ether, and everything that we know as anything, these are just waves in the ether. Which, as far as I know, that's exactly what quantum field theory says.
You're okay. You're very wrong, but okay.
What do you mean? Isn't that what quantum field theory says? That everything is a wave in a field? There's fields. So everything
Yes,
is
the fields do oscillate, and they do sometimes manifest as individual particles, but they do not ever. They have certain properties that are not trivially represented as conventional mechanical physics. So your conventional wave physics, for example, do not apply to particle observations in something like the double slit experiment, because that would imply that all your particles should smear out over the entire observation surface, which doesn't happen. So in quantum physics, what actually is happening is that the wave function collapses down to a single point. That's a very different mechanism than what you would term a wave dynamic in conventional physics and classical physics.
Hold on.
Which is what I think you're trying to say.
Wait. So hold on 1 second. So I'm saying that an elementary particle like an electron, it's a wave packet. It's a wave. It waves through the ether. It holds its own integrity. It doesn't disperse. It doesn't go in all directions. It has a location and a momentum and a mass because it interacts with the Higgs mechanism of the ether. And as
and that's where you are disagreeing with quantum physics.
Why?
QFTs.
I don't. If I ever disagree with big physics, I take it back. All I'm saying is I'm just reinterpreting big physics through the ether. For me, it's just simpler.
Gotcha.
That's all.
So just telling you that what you're describing there is that the electron has a definite position and a definite momentum, I think you meant to say, is definitely incorrect. That is not what QFT says.
Wait. QFT doesn't say that an electron is a wave?
QFT says that the electron is a disturbance in the electron field.
Yeah.
Yes.
Okay.
But the disturbance does not propagate along a specific point. I'm sorry. It does not propagate in a manner to where it would stay together. The disturbance actually disperses out. But what's dispersing is not the electron itself, not the observation. It's the wave function of the electron, which is dispersing out. Well, it's actually the wave function is more of a static thing, but whatever. And when you observe the electron, the wave function, what it says, the electron field, is what it says, that you're going to find an electron at one definite spot, not in a million spots, which would be traditional for a conventional mechanical wave. What you're going to find is you're going to find it in a single spot, but there is nothing in the wave function itself that told it to be exactly there other than just the probability of you finding it there. Nothing more than that. And there are plenty of what you're probably thinking about is the incorrect description of that Einstein was actually wrestling with in quantum physics, where he was saying that the reason why the electron is observed where it is because it was always going to be there. It was never going to be anywhere else. But there was just some hidden variables in there that we didn't know, we couldn't observe, and so therefore we just think that it like the wave function collapsed in purely probabilistic methods, but it wasn't actually there. It was, I'm sorry, it was always going to be there. It's just we didn't observe some internal state of the electron that would have allowed us to predict its position, and that is fundamentally wrong. Have a look at Bell's inequality theorem, and you will see that it's a fairly complicated experiment, but what it says is that there are no hidden variables. The electron really its wave function really is smeared out all over the universe. And the only thing that tells you is the probability of finding the electron at a specific spot. There's nothing a priori, some hidden state, some hidden information inside of the electron before you observe it that's going to tell you where you're going to be able to observe it.
Can you reproduce Bell's inequality without spin?
Bell's inequality applies to quantum properties of objects. It doesn't necessarily mean that it's going to only apply to one quantum property. It's going to apply to all of them.
But I know that Bell offered his inequality about spin, and I don't understand.
Yes, there's just one convenient thing that it could test easily.
So can you formulate Bell's inequality without spin? Can you?
I don't know. Maybe it's possible. I'm not aware of it being specifically tied to any specific property. It's just talking about the generalized function, the wave function of an electron or of a particle, of a quantum particle.
So I would claim that you cannot reproduce Bell's inequality without spin. So this is
Cool story.
Why do you keep saying that? That's not nice. Like, be nice. Like, talk. Like, I'm being very nice to you. Anyway, this is very important. So you need to find out, and so that we can have a proper discussion. If Bell depends on spin. If Bell depends on spin, since we don't understand spin, I don't understand spin.
We don't. Okay.
I don't. So, do you understand
Big physics
spin?
does.
Do you understand spin?
I have a very tenuous understanding of it.
So as long as we don't understand spin, neither me nor you, we cannot have
So
it.
we're going to go with the accepted
No,
conclusion.
I don't. I don't do such things. I argue from first principles, or I stop arguing. I don't accept.
Then I think the latter is actually a better choice.
Yes, which is why I suggested that you come back when you have an answer. So, can you reproduce Bell's inequality without spin? That's the question. So, this discussion about Bell's inequality is a dead end. You cannot submit it as evidence in this discussion.
Can you explain Bell's inequality to me?
No,
Why not?
because it depends on spin, and I don't understand spin. So the discussion is mute. I've never heard an explanation of spin. I've heard many explanations. It just doesn't make any sense. So
Okay.
when we don't understand something, everybody agrees we don't understand something, and then you build experiments on top of that. But already we
So
don't.
do you think nobody understands spin, or just that you don't?
I don't, and I've never heard anyone who does, who says they do. You're welcome to introduce them to me.
Okay.
So if somebody says I don't understand spin, but let me propose an experiment that builds on top of not understanding spin, then of course whatever the conclusion is, it's going to be something we don't understand. Because if you don't understand something and you build on top of that, then you're not going to understand that either. So claiming that Bell's inequality is a violation of whatever, of reality, is
No, it's
nonsensical.
not. It's not a violation of reality. No. You're now. See, you're now extrapolating from not knowing. I'm saying that I don't know all the details and mechanics exactly how Bell's inequality works. I don't have the mathematical underpinnings for it, but I know the conclusions that have been told to me by people who have, and the conclusions are that the theory of hidden variables is disproved. So
I'll ignore that.
with that in hand, talking about people who do understand it,
I don't care.
they are that's your problem. You're at that point you don't actually care about being correct. So in lieu of not either of us having all the mechanical underpinnings to understand exactly how it's done, I'm going to defer to the people who have trained on this for years and years and years and have done successful experiments.
No.
Who do understand it.
No. You do you, I do me, I don't. I don't defer to anyone about anything. I have to understand this universe. Either I understand it or I'm going to continue researching. I don't care what anybody says.
That's fine.
I think it's more likely that you'll just end up making shit up and being completely wrong.
You're referencing me again. I'll just ignore that. Let's continue talking about the universe and not me. So is there any further question?
Did we ever figure out what the insight was, or a testable prediction of the ether interpretation was?
I didn't talk about that because Mr. Totoro kept claiming that I'm not proposing a theory. So I wanted to.
You're not yet. You still haven't proposed any theory.
So it's more important for me. Yeah, and
you're just pointing to pieces of known physics and saying ether.
So
with no.
So Let's say
Omnivore.
that
Omnivore.
you say that there is that light is propagating through an ether,
Omnivore.
or that everything is a wave.
Omnivore. Omnivore. Just before you say something, so let me just respond to Totoro again. As I said before, this is very important. So I used to not understand SR, GR, quantum mechanics, double slit, dark energy. Nothing made any sense. I just couldn't figure it out. And I listened to lectures about these things for years and years and years. And I was thinking about these things for years. I couldn't make any sense of it. And then one day, I came to this realization that there is ether and everything is just waving through the ether. And within a few hours and days, everything snapped into place. So for me, the ether theory, the ether model is the most powerful model I've ever heard of in my entire life, which I came up with it. But nevertheless, it's the most powerful model that I've ever encountered in my entire
You
life.
you came up with
One
ether?
second, one second. Let me finish. So for you to claim that it's not a theory, well, then either you don't understand what I'm saying, or you're lying. So this
Dude,
is why
I'm
I'm
trying to
fine.
get you to get to the
I'm
point.
fine. I'm
So
fine. I'm fine. I'm just again okay. So it's either you don't understand or you do understand, and you're pretending to not understand the power of this model. So if you want to ask me questions, that's fine. If Omnivore want to ask me questions, everything is fine. So go ahead.
dude, you've not yet proposed an actual coherent model. So chop chop, get on with it.
So you're being mean, and that
No, but
indicates to me that you're lying. That indicates to
Yeah,
me
yeah.
that you do understand.
Fast forward. Can we
No,
get to the
no,
meat
no,
part?
no. I'm not here. I'm not here to convince you. I'm here to stress test my theory and have a good time. And if you're going to be
Okay, so
mean,
so
how,
so
how
so
can you test your theory without actually saying something about the theory beyond the thing that you said that you invented ether?
so
what's
so I think if we know what a test would be to distinguish the ether hypothesis from the standard non-ether interpretation,
so it's the truth
that would tell
is,
us a lot.
I think the truth is that any experiment I propose, my fear is that it would be indistinguishable from GR. That's my fear. I didn't check it too much, but that's my intuition. Anyway, there's at least two experiments I can offer. One is the correction to the Michelson and Morley. So if we assume ether is gravity, so based on Newton, ether is flowing through me right now at about 11 kilometers a second towards the center of the Earth.
Fuck.
Okay. All right. If we assume that, then
So,
what?
so if we assume that, so first of all, we could create a vertical interferometer based, once we know this, so we can create a vertical. As far as I know, I don't know if anyone has attempted this test with a vertical interferometer based on looking for 11 kilometers a second. I don't know if anyone has done that. That's one prediction. Another prediction is once we know that it's basically raining ether. So at the equator, we're moving through the ether at about 1,000 meters per
It is
second.
raining ether, you said?
Yeah. So again, so my ether is also gravity. It's also gravity. So Newton's gravity, whatever. Gravity is the flow of ether through me right now. So ether is flowing through me right now. And that is what is dragging me towards the ground.
can you detect ether?
Yes, with an interferometer, of course, because it's also the medium for electromagnetic radiation. So you can use an interferometer, just like Michelson and Morley.
So why nobody measured ether? What are you measuring? Explain.
Just exactly what Michelson and Morley did, but they used an 11-meter interferometer, and they should have used a 10-kilometer interferometer. My calculations show that a 10-kilometer arm radius is basically the least that you need. Now, in order to do a 10-kilometer horizontal interferometer, I can show
Where
you.
is your calculations?
There's many videos in which I derive this number. So
It is getting very dry here. Can you provide something that we can actually taste, or you want to continue with stories?
if you are being mean, then I will probably.
I'm not being mean. I'm actually. You said already like 5 times. I did experiments. I did video. I did this. I did that. I have a calculation. So far, you haven't presented a calculation, and you've been talking for 2 hours about
Okay, so
stories.
I think the idea of doing a vertical interferometry test is a good one. That is the idea that this ether flow is what's pushing us towards the planet. What about Cavendish? So Cavendish has mass attracting mass, right? In a linear direction.
What's Cavendish?
You don't know what the Cavendish experiment is?
No.
Okay.
You want me to Google it?
Yes, you should probably Google it.
Okay, 1 second.
It's a basic experimentation for gravity, and it seems to contradict the idea that ether is raining on us, and that's what pushes us towards the Earth, because it involves lateral motion between two different objects, two masses.
I don't know what the Cavendish experiment is. I'm still looking. So, do you want to explain it?
Hold on a second. Let me. I'll post it in. I'll post a.
Oh,
The
that.
original Cavendish
Okay.
experiment was done a long time
Oh,
ago.
no, fine. Okay, yeah, that's a famous experiment. Sure, I'm familiar with that. That's how they discovered G, no, or something.
Yeah. So, but in this case, the two masses attract each other in a linear direction, in a horizontal direction, not towards the center of Earth. So if weight so if ether flow is what's pushing us down,
Mm-hmm.
then how do you explain the Cavendish results?
So, the way the ether works, the ether is the Higgs, right? The Higgs mechanism is a mechanism of the ether, in my theory of ether.
Okay.
So, ether is flowing into the Earth. Ether flows. So, why does the ether flow into the Earth? So, ether interacts with what we call massive particles, but before it interacts with them, ether is the Higgs. So before it interacts, they have no mass. When it interacts, it endows them with mass. So the very interaction of the ether with the electron endows mass onto the electron.
Didn't you say though that particles are a manifestation of the ether? So it's ether is interacting with the ether.
Well, just a second. So I like the idea that vertical interferometry would show a downwards flow of ether at some rate, 11 meters per second or whatever it was. So that's a testable prediction. However, before we test it, we can see that by looking at Cavendish, we have a case where two different masses attract each other, where two masses attract each other, not in the direction of the center of gravity of the Earth. So how do we how do you account for that? How do you account for the attraction in the Cavendish mechanism? And I posted something in the general chat, Cavendish in a vacuum, because that's a experiment that was done recently, like 2 years ago, I think. And they used all sorts of cool controls for for confounding variables. So they had it in a Faraday cage. They had everything grounded. They had a vacuum around it. They sized their weights so that you wouldn't get Casimir effects. Everything was was on a everything was on a non a vibration absorbing surface, etc. They used gold, so it was not going to have magnetic effects. So they did this really good. They did a really good job of accounting for confounding variables, and as a result, what we see is these two masses attracting each other, as the gravitational theory predicts. So how do you account for that attraction between the two masses using ether?
So, again, I agree with everything big physics says. I'm sorry for calling it big physics. It's not a pejorative. It's just that I agree with everything big physics says. So, big physics explains everything you just asked.
But big physics does not hold that we would detect a downwards acceleration of ether using interferometry.
Okay.
So if the downward force that I feel that's holding me to my chair right now is because of interferometry, or because of ether flow, that is going down from the sky.
Okay, but
that would be a that would be a cause of gravitation.
I don't disagree, but I don't disagree with big physics. So the Cavendish experiment is explained by big physics. So it's explained by me. Just that instead of, let's say, they say, right, so that's the difference. They say it's the curvature. Gravity is the curvature of space-time. I don't do that. For me, it's just, let me just say that. For me, it's just, let me just finish. For me, it's just the flow of ether. So anytime two objects attract each other, so there must be a flow of ether. They're trapped inside the vortices of each other. It's just fluid dynamics. So
fluid dynamics doesn't pull one object to another in a fluid. Okay, that's not how fluid dynamics works.
So imagine every massive particle. Imagine an infinite pool of water.
Okay.
And now you put the Cavendish experiment in this infinite pool.
Okay.
Right? So nothing is happening. But now every massive object converted into a negative pump, into a suction pump that is pumping the water into itself. It's able to absorb an infinite amount of water. Forever can a massive object suck in water. Imagine that it sucks in water and the water annihilates as soon as it enters the massive particle. So you have two billiard balls in the Cavendish experiment. So each of which is now a suction pump that is sucking the water in this infinite pool. It's just sucking it out. So it's creating. There's now a pressure gradient, right?
So what? So in this theory, water or ether is created everywhere in space at all times.
That's
constant creation of ether all around us, and it flows into massive objects, into masses.
Well, slowly. So I didn't say that there is creation. That's dark energy. we can come back to that. But for now, we have an infinite pool. Imagine an infinite pool with a positive pressure. Yeah, you need the positive pressure. So there's an infinite. The universe is an infinite pool with a positive pressure, and whenever wherever you have a massive particle, it interacts with the water, with the fluid, and annihilates the fluid. So this annihilation creates an actual vacuum. Now you have a pressure gradient because in general the fluid has a positive pressure, but at the point of annihilation you have a vacuum. You have a lower pressure, so you have a pressure gradient that creates a flow. So now any two objects that have a mass in this fluid are caught in each other's vortex, in each other's flux, and that's gravity.
Yeah, I don't. Yeah, so I don't know. So that would give us some. So that means that this ether is exerting a force, right? A flow from everything towards every other thing because we exist in a space where all of these objects are sucking in ether.
Correct. There's a flux. Everything, I'm creating a flux right now. You're creating a flux. The Earth is creating a huge flux. The Moon is creating a flux. The sun, the galaxy, the universe. Yeah. And very
Well, I think
Mhm.
I think you will need to you would need to figure out how to test that. If that was the case, then why would I detect with interferometry? Why would I detect a downwards flow?
Because that is the biggest one around. The Earth creates a flux that is much greater than the flux that you're creating, or the Moon, or the Sun, or the galaxy, or Andromeda. So the Earth is right. So that's just the biggest flux around. So that is what you're going to detect. It's going to be very difficult to detect the flux that you're creating. That's all. But that's the Cavendish. I mean, I'm not disagreeing with physics. I'm reproducing all of physics.
Yeah, but then I don't think we gain anything from that. If we don't see a different if we don't see some testable theory to distinguish this from other interpretations, then I'm not sure what we gain. I understand that you gained a lot from it, but I don't see the same informative power.
Well, it gives you special relativity. It gives you gravity. It gives you the particle wave duality. It gives you
but I already have all of that.
Why is the speed of light a constant?
Because it's the fastest that causality can travel.
No.
In the universe.
No. Einstein just postulated. There's no reason for the speed of light to be a constant. Einstein just posits it. There is no reason. Unless you assume.
I think Michelson-Morley detected it as a constant, and it comes out as a constant from Maxwell's equations.
No.
Yes, it does. Have you never done the derivation of the speed of light from Maxwell's equations?
Einstein, again, you're referencing me, so we'll ignore that. So Einstein.
The question is whether you've done something that is sort of,
you're
again,
the
starting point.
Yeah,
so you don't actually understand that.
Yeah, okay. I'll ignore any references you make.
Okay, well, just to let you know, in Maxwell's equations, the speed of light falls out as a constant. Yes, it does.
But it's relative to the ether.
No, it's a constant.
Of the ether.
It's a constant from any frame of reference.
No, it's not.
Yes.
It's of the ether. That's why. That's exactly.
Too bad that you don't believe that, but that is one of the consequences of special relativity. In order to have that's why the paper is called On the Electrodynamics of Moving Bodies, is because he's talking about the fact that the laws of physics, the electrodynamics, the electromagnetic interactions are the same for everybody, no matter how they move. And that is only consistent if everybody has the same speed of light, because the speed of light is dependent upon the electric and magnetic constants. which also scale things like the Lorentz force. So they give you the strength of electromagnetism, basically. And we do not ever observe those changing. So consequently, the speed of light has to be the same for everybody.
So why does Einstein propose it as a postulate and not go through the derivation as you just did?
He generalizes it a little bit more to some other effects as well. But that is, he postulates, what he really postulates is that the laws of physics are the same for everybody, and the laws of electrodynamics specifically.
Mm-hmm.
And from that, you basically get the second statement, which is that the speed of light is the same for everybody.
Right.
So the speed of light being the same in any reference frame means that if I'm going at 99% the speed of light and I'm zooming towards somebody else going at 99% the speed of light, we don't observe each other. We don't observe us hitting each other or coming towards each other at double the speed of light.
Yeah, that's one of the conclusions of that.
Which is really weird, right? It's like saying a head-on collision between two cars going 60 miles an hour wouldn't be 120 miles an hour worth of impact.
Okay, if you feel it's weird, then that's exactly what my ether result. My ether makes.
So why does so if ether is being created and is being sucked into
no
two bodies moving towards each other?
No. SR. Look, that's GR. That's gravity. So now we're talking about special relativity. Special relativity. If you look at my rubber ducky, that explains why the speed of light is a constant if you assume ether. So the speed of light is a conclusion. That's the paper, the proof of the second postulate. I proved the second postulate, but for the rubber ducky. The second postulate works for the rubber ducky.
So in the case of the rubber ducky is in a field of expanding waves.
No, what do you mean expanding?
You have the
rubber
in the
ducky.
center, and then
It moves. The rubber ducky in the beginning, it's stationary in the bathtub, and
Right.
and it measures. It just tick tocks. As it moves, through the bathtub, it still measures the speed of light to be a constant, because the waves are tick-tocking back and forth at always the same rate, because the rubber ducky doesn't have a separate clock. That is its clock. So if your if your clock is based on the waves whose speed you're measuring, then you will always measure a constant speed of waves.
Well, wait a minute.
Mm-hmm.
So in this theory, the rubber ducky, there's two rubber duckies.
No,
they're
one.
Both absorbing.
No, there's just one.
Yeah.
I didn't present two. So we just need one.
Yeah, I understand. No, we need two. We need
No.
two, because we have to have
No,
two
no, no.
observers.
No, there's not. No. The rubber ducky is always measuring a constant speed of waves in the bathtub, whether it's moving or it's stationary. The speed of light. The rubber ducky is just measuring over a distance between the emitter and the detector is a constant.
Do you know why I want two rubber duckies?
I don't want to. I don't want that yet.
Address that. If you can't address that, then
no. I didn't.
Continue.
I didn't do that. We don't need that for proving the second postulate. We don't need two rubber duckies. One is enough.
I'm interested in testing your theory.
But you agree that. But do you agree that the second postulate can be proved from the rubber ducky?
No, I do not agree with that.
Then I need only one rubber ducky to prove the speed of light is a constant. The speed of light is a constant. That comes out of assuming an ether. It's just wave mechanics.
Okay, so I don't agree with that.
Then you don't need two rubber duckies. One is enough. So ask me questions about the one, or I'll go through the one rubber ducky thought experiment, and you.
Well,
Mhm.
if I'm always going to see the speed of light as a constant from whatever reference point
What does that mean?
examine it from.
No, no, no. Let's talk about the rubber ducky. Do you agree that the rubber ducky is always measuring a constant velocity of water surface waves? Yes or no?
When it's stationary, yes.
No, when it's moving. When it's moving,
No.
and so
No.
that's what we need to understand. The rubber ducky is always measuring a constant velocity of water waves, whether it's moving
What if
or
it's moving towards the creation
it doesn't.
object?
No, no, no. It is emitting and absorbing. It has a distance. The clock, the rubber ducky has a clock, the tick tock. It has an emitter and a detector. It knows the distance. It sends a pulse, a tick, and then it gets a talk.
So,
So it
if it's
uses a
moving
clock.
towards the emitter,
No,
what
there's
does
no
it get?
emitter. There's what? It doesn't matter. It doesn't matter. It's always going to tick tock through the distance. So it uses a clock to measure the time between the tick and the talk. How much time did it take the wave to go from tick to talk? It uses that clock. It always gets
Okay.
a tick.
Look, listen. This doesn't. You the way that you're talking doesn't help me any.
Then ask me questions. Did you see the diagram in the
I did.
paper?
I've been trying to ask you questions, but you're refusing to address them.
You don't need two rubber duckies.
Hang on. Just a quick question. So you're saying that the wave crests in the medium that the rubber ducky is observing, presumably, are determining its clock rate?
It doesn't. It. Yes, I mean, it's
Okay.
using. Look, this,
Okay, cool. So let's think about it like this: rubber ducky is moving towards the origin of some sort of a sound, some wave.
No.
Then it's going to observe a
No,
faster
no.
tick-tock rate. Does it clock run faster?
Look. Let's talk about the one experiment that I proposed in the paper. So you have a single rubber ducky that emits a wave and then receives the wave. Right? It has a transmitter. It has a emitter and a detector. It knows the distance between the emitter and the detector, and the very tick tock, that's the clock. See, that is what we are doing right now. Our consciousness, everything works on, right? We're all waving through the ether. That's the analogy. But let's go back to the rubber ducky. So all it has a clock that is the tick tocking, and it's tick tocking through the wave. It knows the distance. So the distance is constant for the rubber ducky, and the tick
So it's not
tocking.
moving.
What?
So it's not moving relative to whatever target
There's no
you're
target.
scattering.
There is no target. The rubber ducky has an internal emitter and detector. That's it. That's the experiment. There's only a rubber ducky and a bathtub. There's nothing else.
Okay.
So as the rubber ducky is stationary, it's tick-tocking through the distance, and it's measuring a velocity of water waves, namely.
But if it's sending out, hang on. If it's sending out those pulses in that water, how does it know where the crests are? The wave has to obviously reflect and come back to the ducky.
No,
right?
no. It's internal. The rubber ducky has an internal emitter and detector. It's internal.
Okay. So it just creates waves at whatever
A single
frequency it
wave.
wants to.
No, there's no frequency. A single wave. It creates
No such thing as a single wave.
It just creates a single up and down. That's it.
Yeah, no, that's still a composition of waves of different wavelengths. So you have to time. You know, you're gonna have a harmonic signal. It's okay to create a short pulse, is what you mean.
It doesn't matter. It honestly doesn't matter.
Then the pulse,
Yes.
to understand when the wave crest or wave trough is, at the ducky,
doesn't.
obviously the ducky generates it,
It's in
then
the.
it has to receive it back when it gets
No.
back.
It's in the dark. It has an emitter and a detector inside it. So it emits
Okay.
a wave and then detects the wave. It's in the dark. It doesn't see anything. It doesn't have
How does the wave get back to it?
It doesn't get back. It just goes from the transmitter to the receiver, from the emitter to the detector. It's one way. That's it.
So it's on the ducky.
What? Everything is inside the ducky.
Okay, cool. Okay, gotcha. Yeah.
So it measures a certain speed of wave.
Yes.
Right?
Okay.
It has a clock. It has a distance. It emits, and when the wave is detected, that's the time by definition that
Right.
it
Yeah.
took.
That's the speed of the wave. Yes.
Yes, so it calculates a certain v speed of wave. Then it starts
Okay.
moving.
Cool.
Now it starts moving through the water in any direction. It's gonna go through the
Yes.
same experiment.
Yes, and it'll measure a different wave speed.
No, it will
It will.
always measure the same because the clock ticks slower.
That's you postulating that that's the case, but that's
No,
not
no, no, no,
what
no,
happens in real waves.
no, 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 no. The rubber ducky has a clock. The clock is the emitter and the receiver.
Okay.
The emitter and the
So
detector. That's the
right.
clock.
Right.
In
So
order.
you're saying that the clock slows down in proportion to speed.
Correct.
Yes, that's not what happens.
What do you mean that's not what happens?
Yeah, that disagrees with the experiment.
It's a thought experiment. What do you mean disagrees? It's a thought experiment.
It disagrees with measurement.
What then? Okay, we're not talking about the same thing. If you're not, if that's.
I'm sorry. Yeah, in
What?
special relativity, your
Forget-
time
forget-
dilation is the
forget-
effect you're
forget-
talking about. Is
forget-
not
forget-
proportional
forget-
to your speed directly.
Forget. No. Forget. You don't need. We don't need to talk about special relativity. So we just
You-
have a rubber.
I thought
Hold
you-
on. No. Hold on. All I want to prove is that the rubber ducky will always measure a constant speed of water surface waves. That's all I'm saying. Whether it's moving or
If
stays
you
in the bathtub.
Okay, if you postulate it that way, then yeah, the time dilation factor for the rubber ducky will be 1 over v.
The rubber ducky
Actually,
will always measure a
let me actually
constant.
correct that. It'd be. I'd have to check, but if we
No.
postulate that the intrinsic speed of the wave is c, then your time dilation factor will be 1 over c minus v.
It doesn't matter. The rubber ducky will always measure the same speed
sorry.
of wave, whether it's
1 over the square root
moving.
of 1
It
minus
doesn't
v over
matter.
c.
It doesn't matter. It doesn't matter.
It actually does kind of matter.
No, the rubber ducky will always measure whatever it was when it was stationary. It will measure when it's moving. So the rubber ducky cannot tell that it's moving or stationary.
That's great. Okay, cool.
That's the constant speed of water waves that the rubber ducky detects.
Right.
That's
You have, yeah. So you're arguing by analogy that time for the rubber ducky changes as the direct inverse of its speed through the medium.
I don't care. It doesn't matter what the math says. Whatever it is, however it slows down, for the rubber ducky cannot notice it.
I'm not even trying to argue some hard math here. I'm just logically extending your argument and trying to quantify it.
Okay, but we don't need to.
It's just a logical argument. That's what math is.
Okay,
It's trying to make a logical argument for what you're saying.
We don't need to. The only math we need is the definition.
We don't need logic.
Stop. The only math we need is the definition of velocity as distance over time. The distance doesn't change.
Okay.
The rubber ducky is not flexible. It doesn't the distance between the emitter and the detector doesn't change. And the time between emitting and detecting never changes because that is the clock. The emitting and the detecting is the clock. So the rubber ducky always measures a constant speed of water surface waves. Whether it's moving slowly, fast, backwards, forwards, up, down, it doesn't matter.
So to be clear, what you mean is that the emitter emits a wave and then sits still and then waits until the receiver receives it.
It doesn't sit still. What do you mean sit still? The emitter emits a single pulse, a single crest. A single crest. It travels in all directions. And then when the detector detects the wave, it detects the wave. The wave has been detected. That
Gotcha.
signal
Okay.
has been detected, and that is a tick. That's the definition of a tick. That's the definition of time for the rubber ducky. The rubber ducky doesn't have any other definition of time.
Okay. Right. Okay. So yeah. Okay. I mean, you've put enough on the table where we can actually put some meat on these hollow bones.
Why do you
You've
call
basically
these
said
hollow
that
bones? This is a proof of Einstein's second postulate. Why would you call
it
this?
actually isn't, but
All right.
whatever.
What's the question? Why do you say
What
it's
you're trying
not?
to actually, so what you're saying is that the passage of time is directly proportional to the speed of motion. It's actually indirectly
I don't
would
care.
it be indirect
I
or direct?
don't care.
But it's a simple linear relationship
I
to
don't care.
velocity.
I don't care.
Okay.
The rubber
So you
ducky
don't care
cannot.
to.
The rubber
Okay.
ducky cannot measure its motion. The rubber ducky cannot know that it's moving through the water.
But we can still postulate it. We can
What do you mean?
still think about it that way.
What do you
Well,
mean?
you said it starts moving, so obviously it starts moving, right?
When we
We
move,
know.
yeah, we know, yeah, we're God. So when we
Okay,
move the
good, good,
rubber
good, good, good.
ducky, but the rubber ducky always measures the same speed of
Yes.
water
So
surface waves, just like
right,
we
right.
all, and that explains why we always measure a constant speed of light.
Okay, cool. So what the time flow for the rubber ducky we're going to call proper time, and the time that we observe that the rubber ducky is seen on between emission and reception of a wave crest, we call observer time, right? And we will observe that the proper time has elongated to the observer time by direct proportion by linear proportion to the speed of the ducky moving
That's the
to an
Lorentz
external observer.
that is Lorentz transformation, sure, but that's not the purpose of this paper.
It actually isn't Lorenz's transformation.
That's
You've proposed a new transformation.
no,
It's
no,
a
no, no.
different one.
What do you mean? This is time dilation. But I'm not here for time dilation. I
It's
don't care. I don't care about time dilation.
well, it has to be a consequence since you said
Fine,
that the
fine,
medium doesn't
fine. But
move.
that's dialect made the video about that. I don't need to make another video about that. Dialect already showed that you can get time dilation just by assuming a fluid. I don't need that. I went one step backwards. I'm going to Einstein's second postulate. I'm asking why is the speed of light a constant? And the answer is because of ether. Are you there?
I mean, you're not really willing to engage with the arguments, so
Again,
I don't
you're
care.
referencing me. I don't know. Please stop referencing me. Just
Yeah,
what's the question?
because you're the one who referenced yourself. You said you don't care, so therefore I don't care.
Do you have any questions? Do you want to ask me something? Do you?
No,
Yeah,
no, no, I don't have any.
I don't think you engaged with the questions.
Again, you're referencing me. So just ask
So
me.
I'm
Do you want to ask
wondering
me?
what you did there.
Do you want to ask me something? Do you have any questions? Do you see the power of the ether?
I
How
don't have
ether?
any questions right now.
No,
I
no, I
don't.
don't have any questions either.
So
Yeah.
to
I
conclude,
don't agree with your conclusions. Your conclusions are erroneous, but you've refused to engage with the arguments. So therefore, end of discussion.
so I'll give my my concluding remarks. So you asked me what is the power of the ether. So that's the power. Ether converts special relativity into nothing more than a bathtub rubber ducky experiment. So if you
Who
assume,
asked what the power of the ether is? I didn't.
you made your concluding remarks. So let me finish my concluding remarks. So if we assume ether, we get a constant speed of light. That's the power. That's just one of the immense powers of the ether. It gives you SR. It instantaneously gives you SR with no weirdness. It's a mechanical SR. it makes SR, it turns SR into a joke. There's no SR. It's just wave. It's not even. It's just geometry. It's like what? It's not even wave mechanics. You don't even need to understand wave mechanics. It's just the way waves are. Waves are waving. That's the power of the ether. That's just one of the tiniest things that you get from the ether. So to say that the theory of the ether is just a renaming of conventions is nonsensical. So, do you have any further questions about the power of the ether theory? Or are you going to remain silent? Amazing. Let me see.
I got a question.
Go ahead.
The power of the ether theory sounds gay as fuck.
I couldn't hear you. What? Please repeat. Hello? Incredible. Incredible. So when you guys are all together, you don't stop laughing at me, but when it's like one-on-one, I mop the floor with your faces.
You didn't mop anything, buddy. You simply ran away when you were pressed on the mathematical implications of your own claims.
I'm still
You said
here.
literally, and I quote, "I do not care. I do not care." So, if you do not care, then how do you proclaim victory? All you are is basically a pigeon strutting about on the chessboard.
Okay, again, you're referencing me. So about
Yes.
So do you have any
That's because
questions?
you just referenced everybody else here in the VC that you mopped the floor. It's about the only thing you did was
I
mop
was
your
going to say,
face.
I don't think you mopped. I have to say, I don't think you mopped anything.
So ask me questions. Stress test my theory. Come on.
I did, and
just
you
said
said
that-
you don't care.
Right.
You just set him up to the floor with your face to try to get you back into the conversation. Because we don't engage him and he wants us to engage him. So he's trying to trigger us into engaging him back.
Yeah, when I tried, he basically said, "I don't care. I don't want to engage with it." So
No, it's
end of discussion at
I
that point.
explained. No. I explained it's irrelevant. It's irrelevant. It doesn't matter.
It's very relevant.
No, it's not. No, the second postulate, there's no equation. We always measure the speed of light to be a constant. Why is that? If you assume ether, that's what you get. A constant.
Yes,
That's it. You don't. I'm not here to discussing the actual time dilation. That's Einstein already explained that. But it depends on the second postulate. The second postulate depends.
Well, the consequences of that Einstein explained from the second postulate is time dilation and length contraction, and you just said that the rubber ducky does not change length because it's rigid. So that's already a contradiction right there. Then you basically are trying to explain it as a mechanistic waving in a medium.
Hold on, wait.
You're trying to explain it as mechanistic waving in a medium.
Wait, hold
which would
on.
imply that.
Wait.
And you also linked. Hang on,
Wait.
let me finish.
No, but
and you also imply that time passage for that the ducky measures is based upon the transmission and reception of a wave crest, which in a physical medium propagation of a wave, the wave speed measured relative to a traveling object will be a linear relationship based upon the object's speed relative to the medium, which by consequence then would mean that since you said that the time measurement for the rubber ducky will be based upon the distance, that would imply basically that the rubber ducky's time dilation factor is linear with speed, which is not the case for Einstein's special relativity or Lorenz's transformations. So That is what I was trying to impress onto you, and you said you do not care. So then I don't care.
Okay, hold on, slow down. So when you start speaking and I ask you to please stop and I want to interject and I want to understand what you're saying, I don't see the point of you going on a monologue. I'm not I didn't follow the first few words. What's the point of you going on
Why
and
are you
on?
why are you bringing me into the discussion? I thought this was about the argument. I thought you weren't the kind of person who would attack a person.
I'm not attacking. I'm just talking right now about how we're having a conversation about.
Don't bring me into the conversation. Talk about the physics.
I'm talking about the conversation. I'm talking about how to have a conversation. I'm not talking about you. I'm talking about how to have a conversation. So when I have a conversation, my preference is if at any point you want to stop me, please stop me, because there's no
Yeah,
point.
well,
Let me just
it's not
finish.
it's
Let me
not my
just
preference, so that's okay.
let me just finish. So I understand that it's not your preference, but it's my preference. So when you're saying something, when you're saying something and I don't understand it, and I'm trying to stop you in order to understand it, but you're continuing on and on, and I'm not following, and I already had a question on the first thing you said, and you bring up more and more and more and more points, which might all be legitimate, but what's the point? I'd rather, if you don't mind, if you want to help me, because this conversation, as far as I'm concerned, it's about me. I'm trying to stress test my theory. I'm curious to know if my theory is correct or not. So if you don't mind, let's have a more of a ping pong of a conversation. So, like, it's not important to finish. It's important for me to understand. So, do you want to ask what you asked again?
Yeah, well, Bacon here in chat is saying that he's bored and he probably wants to talk about something else. So if you have a topic you want to bring up, Bacon, oh, he's actually deafened because he's bored to shit. Let's see if he comes up in voice.
Okay, so if you don't want to continue, I'll leave. But I thought you wanted to bring up a point. I mean, you said something. You said so many things, and then when I asked you to please break it down so we can actually negotiate each point, you refuse.
I brought up multiple points, but I mean, it might be too much for you, I guess. That's okay. I'm bored. I'm bored with this stupid argument, quite frankly, from you. So
you brought
I'm
up.
just gonna go ahead and move on. So
You
Bacon, if you wanna change topics, that's okay. I'm literally bored to tears after this.
you brought up multiple points. When I ask you to slow down and let's discuss them one by one, you refuse.
Yeah, sure, whatever. Bacon, you got something you want to talk about?
I'm not sure you want to talk about it. How familiar you are with linear algebra?
Me or Mr. Slade?
Yeah. No, you.
I've got some, passing understanding, but I'm not super great at it.
Right, because remember that Minkowski diagram that I created?
Yeah.
Maybe I didn't show you. Okay.
Maybe I'm not sure. I mean, I've seen a Minkowski diagram. I'm not sure if you've ever seen something you've done about it.
Okay, I'll show you then. Tell me when you can see my screen.
You mean the animation there? Right. Yeah. Cool. Yeah.
Okay. Yeah, so I want to build another one. But this time I want to do a better job. Like this one I did very quickly because I did it like just wanting to test the train thing. So I just wanted to have any lines that I could do a Lorentz transform. Now I want to do a little better. So I want to be able to, for example, select this line and press a button that will automatically make the transfer that make this line straight up. something like how do I make that line straighter?
I think you made it faster than the speed of light. That's why it's not doing it. Because
Right.
it's past 45 degrees.
Yes. Okay. So something like this. So I click the line and then I get it to be vertical. Let's say.
Yes.
Or, for example, I want to have an origin for my coordinates. Is, for example, I this point here is my origin. That green dot. So if I'm as I move my mouse, it shows the position and time of each point. I just hover the mouse over.
Wow. People are people. So when they're all together, they don't stop mocking me, but when it's one-on-one, they get upset and get bored, so called. Okay. Hello, hi. That's from over an hour ago. Okay, I mean, I think maybe we should separate these videos. Like, this is one video, so let me just rename it. So this was actually a debate about ether theory in quantum mechanics and general relativity and special relativity. Quantum mechanics, general relativity, and special relativity. Debate with, what was his name? Well, it doesn't matter. Debate, maybe just debate colon ether theory, ether theory in quantum mechanics, general relativity, and special relativity. Yeah, it's okay. Using ether, applying ether, applied ether, applying the ether theory, or my ether theory. My ether theory in quantum. Okay, applying. Okay. So that's going to be the name. All right. I never even checked. Did I check the audio?
So they did this really good.
But if we
No.
postulate that
So when you guys are all together,
Bacon, if you wanna.
So when they're all together, they don't stop. Yeah, the audio is good. Okay. Let me check notifications. I mean, obviously, I mopped the floor with their faces. That goes without saying. The only way they could pretend to survive this debate is by, usual techniques of making multiple points without letting me even ask a question, and then refusing to go point by point, and then disengaging, accusing me of disengaging, ad hominem, referencing me. Yeah, it's he tried everything because he couldn't handle. Obviously, he couldn't handle my position. Let's. I don't want to. I want to keep this video maybe completely all about this debate. It was a good debate. It was basically, I would say, even maybe my first debate, one of the first debates that I'm probably going to have with Big Physics about my theory. So, all right, let's stop here, and I'll be back. See you.